Hi. So today we're finishing lesson 22 on sketching quadratics or parabolas in vertex form. So if you haven't watched part 1 of the video, then I suggest you go back to the previous posting and complete that first. But this is what it looks like. So yesterday you started the lesson and today you're going to finish the lesson. So find that lesson. If you have to pause now to get it out. And then we were on, I think, page 4. So you should see this equation, y equals -2, x plus 2 squared plus 8. Just refreshing your memory again from yesterday. The vertex form is this y equals a times x minus h squared plus k. That's called vertex form. And the A tells you it affects the step pattern. So the step pattern changes from our normal 1, 3, 5 to 1 times A, 3 times A, 5 times A, etc., 7 times A, etc. And if A is negative, so a negative A, our parabola would be upside down or a vertical reflection. And a positive A just stays the same, normal. And H is our horizontal shift, left or right. And K is our vertical shift, up or down. And the reason this one's so graphing friendly again is because our vertex, that's why it's called vertex form, our vertex is at HK. That's where our new vertex would be, at HK. And then we use our A value to figure out what our step pattern is going to be to draw the rest of the parabola in from the vertex. Okay, so a little quick recap, but if you've watched yesterday's video, you should already know all of this. So here's our parent function again, the most basic parabola, y equals x squared, and we are asked to draw the graph of y equals -2, x plus 2 squared plus 8. So again, if you remember from yesterday, the first thing we do is figure out our values of a, h, and k. So our a value is -2. Our h, again, it's -2 because I went over this yesterday, but when you see x plus 2, it's because it was x minus -2. And you don't leave double signs, so it appears in the equation as x plus 2 squared. But h is actually -2, meaning we moved to the left 2 units. And our k is +8. So our vertex, again, vertex form means our vertex is hk. And so we can plot that onto our graph. So our new vertex is at -2, +8, right up at the top here. And then our step pattern is based on our a value. So we can see our a value is negative, so we know our parabola is going to be opening downward. And we know that we multiply 1, 3, 5 by -2. Okay, so our normal one, it would be like +1, +3, +5. But now we multiply each of these by -2, so that's going to be -2, -6, -10, ... Okay, so you take your 1, 3, 5 and multiply by the a value to get your new step pattern. So once I've plotted my vertex, from the vertex I'm going to go over 1, down 2 on each side. And then from this I'm going to go over 1, down 6. 1, 2, 3, 4, 5, 6. Over 1, down 6, and then over 1, down 10 on each side. And then I can draw in my parabola. And that parabola is our y equals -2 times x plus 2 squared plus 8. Okay, and the axis of symmetry again is the vertical line, that the mirror line as I call it, goes right through the vertex. And its equation, because it's a vertical line, is always x equals whatever h is. So our axis of symmetry is x equals -2. It's our mirror line. And then our transformations from y equals x squared, well, we can see that we're flipped upside down. That's the negative sign, so we call that a vertical reflection because we've gone from opening upward to opening downwards. It's also narrower because our step pattern changed. Our steps are bigger, so we call that a vertical stretch. And we doubled our steps, so that's by a factor of 2. So that's A. It's got 2 different transformations. Remember, we don't say by a factor of -2. We say by a factor of 2 because we've doubled our steps. It's the vertical reflection that makes it upside down. That's the negative sign. Then we've moved, our vertex has moved to the left too, so that's called a horizontal shift. And specifically we move left 2. And then we also have a vertical shift. So our vertex moved up 8. So vertical shift up 8. So there's 4 transformations there. The negative sign is one of them. The 2 is one of them. That's our vertical stretch. The -2, the h is a shift, and k being 8 is a shift. So we've got 4 transformations there. A reflection, a stretch, a horizontal shift, and a vertical shift. All right, our next one, y equals 1/2 x squared minus 3. And again, some of you may look at it and say, that doesn't look like it's in vertex form, but you can always exaggerate it. If you just see x squared by itself, it must mean that h was 0, because that's the only way you would get just x squared, because x minus 0 is just x. So that's going to help us fill out our a, h, and k easily. So a is 1/2, h must be 0, and then k is -3. And our vertex, since it's hk, is 0, -3. So I can plot that here. Remember, this is our original parent, y equals x squared. And then our step pattern, so it's changed because a is changed from just being 1 to being 1/2. So it's still positive, so we're going up. Instead of up 1, 3, 5, we're going to go up 1/2 of 1, which is up 1/2. Up 1/2 of 3, which is up 1.5 or 1.5. Up 1/2 of 5, which is up 2.5. And then you can see up 0.5, up 1.5, up 2.5, it would go up 3.5, and then just keep going until you run out of room. So let's apply that. So over 1, up 1/2 on each side. Over 1, up 1.5 puts you on a corner. Over 1, up 1, 2.5 is in a halfway again. Over 1, up 1, 2, 3.5 puts you on a corner again. And we don't have room for 4.5, so we just draw in our nice parabola. Arrows on the end, label it, y equals 1/2 x squared minus 3. Our axis of symmetry goes right through the vertex of our image function. So it's still x equals 0. And our transformations from the parent, we can see it's wider. Okay, that's our a value changing to 1/2, so that we call that a vertical compression. So we've smushed this down. So a vertical compression by a factor of 1/2. And then we can also see that it's been moved down. The vertex has been moved down 3, so we call that a vertical shift. Up and down goes with vertical shift. and that's down 3. So those are our two transformations. Remember, when A changes and it's not 1, then our shape is different. They're not congruent. If I cut this one out and put it on this one, it would be wider. Okay? All right, one more here. So we've got y equals negative. There's a little 1 then that you assume is between the negative sign and the bracket. So a is -1, h is 4, and k is 3. And we know our vertex is hk, so 4, 3. So we can plot our new vertex. I'm just going to put arrows here and label this one y equals x squared. And our new vertex is at 4, 3. Right there. And the step pattern, our a value is -1, so it's changing from +1, +3, +5 to -1, -3, -5. And the minus is going to indicate down for us, right? So here we're going to go over 1, down 1 on both sides. Over 1, down 3 on both sides. Over 1, down 1, 2, 3, 4, 5 on both sides. If we had room, we could go over 1, down 7, but we don't. Try to make your parabolas curvy. Should be getting better at them the more you draw them. And this is y equals -x minus 4 squared plus 3. And our axis of symmetry goes right through the vertex. It's a vertical line, so in this case it's the vertical line x equals 4. And the transformations from the original, so we can see it's upside down, so that's called a vertical reflection, because instead of facing upwards, it's facing downwards. And up and down are vertical words. We can see that the vertex has been shifted right 4, so we call that a horizontal, left and right is horizontal shift. And that would be right 4. And then we also can see that we have a vertical shift. Our vertex has been moved up 3 from 0, 0. So those would be our 3 transformations from the parent function. Okay, then what comes next is just a summary again. The vertex form of a quadratic function is y equals ax minus h squared plus k, where the vertex is hk. So helpful for us. So that's why it's called vertex form, is because right from the equation, you can figure out where the vertex is. The axis of symmetry always has the equation x equals the h value, because it goes right through the vertex, vertical line. If a is positive, the parabola opens up and has a minimum value of k. So let's look at that. If a is positive, the parabola opens up. So if we go back to ones we did on this page here. So here a was positive, and our parabola opened upward, and the minimum value was the k value, -3. Okay? Whereas if a is negative, you've got your upside down parabola, and it has a maximum, so no points higher than, still the k value is 8. Okay, so if a is negative, you get a maximum or a highest point. If a is positive, you get a minimum or a lowest point. And it's always going to be that k value. If you look back through all of your examples, so here's another example where we had the a was negative, which means we should have a maximum, and the maximum should be 3. And sure enough, this graph never gets higher than 3. Okay? And then the step pattern is always up or down 1 times a, 3 times a, 5 times a. And if a is negative, that's the down. If a is positive, that's the up. Okay? So we should be able to use these properties to just be able to complete this chart based off of just knowing the equation. Okay? So for instance, If I was looking at this one, I'd be like, well, I know my A is 1, my H is -3, because I see a positive there, and my K is 4. So even without writing that down, some of you may already know the vertex is -3 and 4. The step pattern's the same because A is 1, so it's +1, +3, +5. And then the transformations would be, that's the same step pattern, so there's no vertical stretch or vertical compression, and we're not upside down, so there's no reflection. So we've just shifted. So we have a horizontal shift, which would be a left 3, and a vertical shift, which would be up 4. Now, again, if you were not too sure about this stuff yet and not too confident with it, you could type in this equation into your Desmos graphing calculator. And actually just get rid of this, delete. And type in my y equals, so bracket x +3 bracket squared, arrow over, +4. And it shows you the parabola. It shows you the vertex is at -1, 2, 3, 1, 2, 3, 4, which is what we had. If you click on it, it says what it is. And we can see that compared to the original, which you could also draw on in a different color if you want, y equals x squared, we know is our normal parabola. It's been shifted left 3, 1, 2, 3, and up 4. So we've got our shifts correct as well. So Desmos is definitely a handy tool to use, especially when you're learning. Okay, it's really good to check that, and you guys can all use your phone with that to check your answers. So for this one, our next one in our chart here, some of you might still want to exaggerate and this x to x minus 0 squared plus 10. So it's easy to pick out that A is your -2, H is 0, and K is 10. So your vertex would be 0, 10. And our A value has changed, so we multiply the 135 by -2. So that gives us 1 times -2 is -2, 3 times -2 is -6, 5 times -2 is -10, and that negative is indicating down. Okay? And so we have some transformations here. This negative sign means we had a vertical reflection, that it's upside down. The 2 means we stretched it. It should be narrower, so we call that a vertical stretch. And we doubled all our steps, so that's by a factor of 2. And then we also moved up 10. So that's a vertical, K is our vertical shift, and it would be up 10. And again, if you're not sure, then you just come back to your Desmos and make sure that everything lines up. So I'm looking at this equation here, so I'm going to change this one, delete it, and make it y equals -2 x squared plus 10. And let's see, my vertex is at 0, 10, just like we predicted. Let's see, is that a point right there? Try to find my point. Yeah, 1, 8 it was when I clicked on it. But over 1 down 2, you can see that's what we did. And so it's stretched. This is over 1 up 1. Here we have over 1 down 2. So we have our vertical stretch by a factor of 2. It looks narrower, and we've been shifted up 10. Our vertex was shifted up 10. Okay, last page. So here again, our A is 1/2, our H is 5, and our K is -2, which means, oops, K is -2, which means our vertex would be 5, -2, and a is a half, so our step pattern is going to be plus a half of 1, which is 0.5, plus 1.5, plus 2.5, etc. And our transformations, so if I see that half there, I'm going to say it's a vertical compression because I'm halving the steps. And when compression goes with fractions or smaller numbers, so compression by a factor of 1/2. And we have a horizontal shift, and that is right 5. And we also have a vertical shift, down 2, and then I'm going to go on Desmos again, type it in, and see if I get, what I think I should have gotten. So I'm going to change again this equation. 2y equals 1 divided by 2, arrow over, there's my bracket, x minus 5 bracket squared minus 2. So you can see that it's wider. There's our vertical compression by a factor of a half. It's been shifted right 5, we can see that easily, and down 2. So it matches what we said. And our vertex is at 5, -2. And our last one, y equals negative, bracket x plus 6 squared. So our a is -1. Our h must be -6. Again, because would have had to have x minus -6 squared in order to see the +6 in the brackets. And there's no k value, so the k must be 0, which means our vertex hk is -6, 0. And our step pattern is just going to be negative or down. So down 1, down 3, down 5, etc. And that's going to lead to 2 transformations. So we have a vertical reflection. And we've got our horizontal shift. And it's left 6. And again, we can just check that quickly on Desmos. So I wouldn't want you to just type it into Desmos. I would want you to predict first and then check your work on Desmos. And then it's a learning tool. So let's type this one in. Negative bracket x plus 6 squared. And you can see, get rid of the computer here. We've been shifted left 6, our vertex, and that was one of our shifts. And we've got a vertical reflection happening upside down. Okay? All right, so our success criteria. So what I want you to be able to do is sketch the graph of a parabola given in vertex form by determining the direction it opens, its vertex, and its step pattern. Understand the role of A, H, and K in that parabola. So what do they do? What information do they give you? And you can write the correct transformations in words that describe how the parent function y equals x squared was transformed into that image. Okay, so after you finish copying down the lesson, you're going to complete the practice from yesterday.